Now it's fine. I was just saying welcome and how difficult it is to study in this topic with respect to programming languages. Programming language studying is easy, but if you want to understand Descartes, for example, you have to read his books, which I didn't. So it is very difficult as compared to computer science fundamental topics. So Descartes was father of modern philosophy. He invented Cartesian coordinate system. He also talked about scientific procedures, mathematical, what is mathematical knowledge, what is scientific evidence, scientific reasoning, etc. So he was famous, and it was around 1600, early 1600s he lived. I think, therefore, I am. So logic and deduction and reasoning, that's one famous thing in reasoning. As other scientific people, he rejected religious authority in the search of scientific knowledge. At those times, some of the scientists were also priests, religious people, because they were the ones who are able to read and write. They were the ones who are able to freely think without working, without obligatory work in Europe, because in Europe there was a class of people who has to work for the lords. What was the name of it? Üniversite sınav sorusu. Serfs. Serfler vardı ya. So serfs they were similar setup in Anatolia, in Ottomans too. Villagers has to work for the lords. Tımar systemi in Anatolia. If they don't work, they are punished. So it is not kind of slavery, but similar to slavery, semi-slavery position. So therefore, only very rich upper class landowners given by the king or religious people were free, kind of free. So scientists were either rich or rich people's friends or supported guys, or people in the church. So there are a lot of in Ottoman and Islamic world as well. Religious people, some of them are interested in science because they were free from work. Descartes said, rational justification for an universal mathematical quantitative understanding of nature. He argued on that. And with the Descartes Cartesian coordinate system, x, y, and z in 3 dimension, that's the center. We still rely on Cartesian coordinate system today to understand the universe. Before that, it wasn't. Descartes was an early stage. Descartes and other philosophers in 1600s said religion and science can coexist, but should be separated a little bit. But it was still early in those ages. It was until 1700s, after Galileo's time, etc., after French Revolution, people started to think separately from the religious ideas in terms of science. Yes, talk. Evet arkadaşlar, uzaktaki arkadaş soru sorabilir. Yazarak sormayın, ben açık görmüyorum. Konuşabilirsiniz. Peki.
Hocam soru değil de katılamayan birisi varmış da bakabilir misin? Tek atmış.
Ses açık. Sesim geliyor mu arkadaşlar? Geliyor bakalım. Derse gelemeyen varmış. Kayıtları dinler, şimdi bölemem. Ne kadar böldüm zaten. Up until Darwin, predominant understanding of the world came from the Bible and church doctrine in Western world. In Eastern world, other religions. In India, it's different. In India, for example, people believe that they reborn again and again, etc. So people had prejudices, pre-accepted values. It was very difficult to change those. There was always conflict. The conflict was more significant in Christianity because the church was too strong. In other religions, including Islam, there is no solid organization called church. More like different people, followers, etc. But in Christianity, there is a pope. A pope says something, it is accepted as a rule, etc. So they want to govern the entire Europe. They wanted to govern the entire world. So in order to keep their power intact, they had to make people believe in certain things as they wish. So the conflict was very significant among church and scientists in those places. Yeah. There were different things that created conflict. One of them was Earth is created in 6 days. So that prevented people searching for age of the Earth and how evolution is incrementally happened, etc. Earth was around, everything was around Earth idea was important, and it was said to be in the Bible by the church. So when Galileo coined, or Copernic as well, said the term Earth is rotating around the sun, church made a resistance. They said no. Age of the Earth, how old the Earth is, was computed based on Adam and Eve and 1,000 years ago, Earth is created, etc. Then people understood it wasn't the case. Then there was a conflict, and the conflict was very strong. We don't see that in Islamic world for that part. I mean, in Islamic world, they don't care that much. But in Christianity, in those years, in 1500s, the conflict was very important. As we indicated, there were religious people who were thinking positively and thinking in scientific base. One of them was Papaz Usher, bishop. He calculated the first day creation to have been Sunday, 4004 BC. They made calculations based on stories happened in Bible and the prophets, etc. So based on that calculation, they were very into calendar things, calendar calculations, dealing with dates and computations, etc. So that was actually a pretty much correct calculation for Middle East history, for early Egyptians and Phoenicians, and the invention of the alphabet, etc. 4000 BC is actually a good date. But it's not related to creation of the earth. Stability of the earth, according to Christians, earth is created in the result of two factors. One is the original creation, and then the Prophet Nuh, the great flood. So all the date calculations are based on these. Before that, there was nothing, etc. So this also challenged by the scientists. In those years, they didn't know about dinosaurs. They didn't know about evolution. They just said Earth is created like this. It was like this all the years. So even if you believe in creation for now, creation can be implemented by evolution. So no problem. But with the church, they were against it. So they said it was created like this. In Islamic world, also there are people thinking that way, but most doesn't. So that was one of the conflicts as well. No species had been lost. No species had changed. So it was completely against evolution in the church. But they forgot they understood selective breeding of dogs and birds, etc. was possible. So they understood breeding changes the species, but they didn't accept evolution as a result of that. Again, religious people taught about creation, understanding the problems with the Bible, etc. John Ray said it was little later than Descartes. God could be understood by only studying his creation, Earth. So he promoted science as a way of going into more deeper level in the religion. So in order to understand God, you have to understand science, etc. But same thing was said in Islamic world as well. In order to understand God more, then you have to understand nature more. He defined species of living creatures. Most of the scientists in those years tried to make taxonomies. So they tried to, taxonomy means classification and organization. They tried to make organized classification of objects, organized classification of stones, organized classification of stones goes to elements, organized classification of species, living species, organized classification of trees, etc. So that was a particular way of doing science classification. Actually, it is. He spent a lot of time thinking about the relationship of organismal form to function, shape and function. Four-legged animal walks, two-legged animal walks with the birds fly, etc. So living things, as he described, living things showed adaptations to environments which were the signs of God's design, and then he said it has to be studied. So he kind of invented in those years, well before Darwin. He kind of invented evolutionary ideas in order to study creation. He studied because they were rich, or they don't want additional earnings due to religious reasons. They just wanted to study things for pleasure. They do classification in physiology, function, and behavior of animals and plants. 1650s are good years for science. Torricelli, Italian scientist, we call them scientists, but they are actually wise guys doing certain things, wise and rich, or sponsored by rich. He was interested in how air pushes water, the tube. He did an experiment with the water tube. How long was the water tube? Tell me. If it was mercury, it was 76 millimeters, because mercury is heavy. When you have a stick filled with mercury, you turn it upside down. So the bottom part and upper part of the mercury is 76 millimeters. This part is what? Empty, clearly empty. So what if it is water? How much? It's grams. Spatial density of the mercury is about 13 grams per centimeter cube. Ten meters. Okay, 10-meter water rises. So above 10 meters, it cannot go. There is a vacuum. How many of you have farmer relatives? Do Did you ever use hand pumps, tulumba? Probably not. You did. What is the maximum pipe length when you have hand pump at the surface? 10 meters, theoretical maximum. Practically, it is 6 or 7 meters. After 6 or 7 meters, the vacuum starts to form. Vacuum starts to form, and the pump doesn't work. Doesn't work. What they do is put the pump at the bottom and pump from the bottom. You cannot vacuum. You cannot take the water from the surface by vacuuming, by pulling the water by an engine, by an electric motor, because after 10 meters, vacuum starts to form. So you can't do it. You have to put the motor down to the water level, then push the water up. That's possible. So Torricelli did that and concluded that the weight of the air pushes, atmospheric pressure pushes this back to tube. Otherwise, doesn't rise. That was very interesting because that gives you the ability to do weather forecast. If the atmospheric pressure is moving down, that means some clouds are coming. It's going to rain. If it is increasing, then it is not going to rain. Pascal. Florin Perrier. Is it related with the water, famous water? No, it is with double R. Perrier. They went up the mountain and understood that atmospheric pressure is lower when you go up to the mountain. So that's what they found in 1648. Boyle. In those years, chemistry is one of the things that people like to play with. One type of people goes to chemistry, and some of them they try to create medicines. Some others try to create gold. Call them alchemists. And some other people try to invent machines with rotating things and hammers, etc. This is one chemical guy. He invented air pump. He invented Boyle's law, expansion and contraction. And he was into Royal Society of London in England Kingdom, established a science division, let's say division, and they called them Royal Society. Royal Society was an organization that makes interaction between scientists possible. They have newsletters. Then later they created journal, printed journal, like today's journals. In 1665, that first journal of the scientific journal of the world, that was Royal Society. So Royal Society of London was very important in Europe as an authority. They introduced the system of public verification, meaning publication of scientific work by journals is invented by Royal Society of London, and Robert Boyle was one of the founders of those years. Boyle's experiment. So this is for visualizing. in those years, magic, science, alchemy, they're all mixed. So talk, because when you are an educated person, when you are a scientist, you know everything. You know medicine, because there are not much knowledge in the world. You know medicine. You are a doctor. You are a scientist. You are a chemist. You are mechanical guy. And you're also a philosopher. People like to talk to you. That's why we see most of the scientists in those years are also philosophers. They have books of thought as well. Newton was an ingenious guy. He thought about light, motion, gravity, dynamics, theology, alchemy, and famous publication is Naturalis Principia Mathematica. That's Latin. Its publication. He talks about motion, Newtonian rules of motion, like acceleration, velocity, etc. All the things. And he also thought about light. Prism is invented by, how prism is working is invented by Newton. Although the rainbow was available on air, nobody studied it. So Newton studied it. Gravity, the famous apple thing, was studied by Newton. Okay, we will come back to these guys from time to time, but first let me go over how science is followed. Science is grown by people, which is called scientific method. Some of the knowledge, how do we acquire knowledge? Where do we get the knowledge from? Some of the things we are told. This is the thing that we are told. They say, world is created in 6 days, and we accept it. That is method of authority. In the previous hour, one of you guys said, why are we adding one? Why are we switching the digits and adding one to find the negative number of a positive number in binary in 2's complement form? I said, because the professor said so. That is method of authority. You don't ask questions. It is not science. Second, logic. If I kill you, you cannot talk. So logically, if I want to talk, I don't kill you. Pretty easy. So certain amount of knowledge can be found by deduction, by logic. Third is the scientific method. We call it inductive reasoning. We ask questions, we do experiments, we solve problems, we develop things, we validate things. Once we validate things, we can put additional things on the previous things. And that is what science is. Validation, asking questions, and so on. Therefore, most research is empirical. There is a need to verify the results of the research, the famous CERN accelerator. What they do is, there are theories. They want to prove the theories by experiments to understand nature. They built a big accelerator, and using that accelerator, they want to eliminate the force that repels two atomic particles from colliding each other. In order to overcome that force, you have to hit very hard. In order to hit very hard, you have to be very fast. That is what that accelerator is trying to. So that they understand what happens if they are very close, what happens if the pressure is very high, like in stars. So how to generate new particles and new forms of matter and energy. So scientific research, scientific method is concerned with users and clients as well as the computer and the software in today's world. Research, when we are doing research, there are empirical studies. There is an empirical study going on. And on the other hand, today, many decisions by the government, by the people, to select what you eat. How many of you smoke? Just 3, 4, 5, 6. Okay. So it is not based on scientific evidence. You just like it. And you say, my uncle was 85 years old. He was smoking 3 packs of cigarette, and he lived until 85 years so that I can smoke. It is anecdotal evidence. It is not science. There is an example. You have seen it. Sometimes you didn't see it. You didn't see it. You just heard it. So many decisions today are based on anecdotal evidence, such as things in programming languages, etc. In general, scientific method is of 4 steps, is made up of 4 steps. First, you see something. You see that your dad was smoking and he died early than others. So what is going on? If you smoke, you die earlier. What's going on? That is what noticing is. Oops. Noticing a phenomenon. My dad died early because smoking. Not because smoking, but early. Why? 2. Anything different than others. Smoking. So you hypothesize that smoking actually shortens the life. It could be based on the numerical numbers. Those who smoke died earlier, 5 years early. For example, in Russia, life expectancy of man is shorter than woman, with a bigger significance than other nations. Why? Yes, because of drinking. But when you just look at the numbers, they are shorter in life than others, than women. So your hypothesis is genetically Russian men are aging faster genetically. That's one hypothesis. The second hypothesis, what is going on to these men than others? They eat something different. That's intake. They drink something different. That's vodka, right? Then some other things. So you just put those hypotheses one after another. But you want to test those hypotheses. You need to do experiments. You need to do experiments. With those experiments, you divide Russian men. Half of them, you don't give vodka for 30 years. The other part, give vodka for another 30 years. And when they die, take the average of ages. If there is a difference, your hypothesis is true. If there is no difference, your hypothesis is false. Right? What if the people who didn't drink vodka was from certain region, like Caucasia, like Azerbaijan? Their life expectancy turned out to be longer, and they didn't drink. So is it because they are Azeris, or is it because they didn't drink? How do you solve this problem? Yes, either with another experiment, or when doing these kind of experiments, you have to take other considerations into account. You have to find people randomly from different places so that those parameters are satisfied. So you refine and retest explanations. If the explanation is true, if the explanation is aligned with the experimental results, then your explanation is true until a further theory is coined, is found and explained by experiments. That doesn't make your data incorrect. Usually, further theory explains unknown details of existing experiments. For example, people died earlier, but how much? If there's a further theory and further experiment is done on top of that, that may predict how long your life is going to shorten if you drink vodka or rakı, for example, which one shortens how much. Or if you smoke in addition to drink, what will be your life expectancy? So that is kind of similar with Newtonian Newton mechanisms and quantum mechanisms, quantum mechanics and Newton mechanics. When you introduce quantum mechanics, Newton mechanics is not disproved. It is still correct, but when you look at very small scale, then quantum mechanics starts to be observable. If you look from distance, it's still Newtonian. So new theories and new experiments usually does not contradict with the old ones. They just explain further, unless the previous experiment is incorrectly done. If it is incorrectly done, then sometimes on purpose, then you can obviously correct it. Scientific method is tedious and time consuming. It is not easy, especially if there is a previously accepted incorrect theory, such as Egg increases cholesterol. Egg increases cholesterol. That's an hypothesis, and it has been validated. It hasn't been validated, but the theory says egg contains cholesterol. So if you eat it, that's logic. If you eat it, your cholesterol should go up. And for years, doctors prescribed not to eat egg for the older people because it increases cholesterol, because it contains cholesterol. What can happen? Later, they did studies, understood that you can eat it, but it doesn't increase cholesterol because you digest it. So previous theory is disproved because it was incorrectly studied before, inadequately studied due to several reasons. They couldn't measure it, etc. Ara vereyim mi? Vereyim. Bir ara vereyim. Şunu düzeltin. Okay. Let's give a break. Ben de bir çay alayım. Geleyim ya.
Hocam CS'ye yüzünde Kuru Şiir diye bir kitap demiştiniz. Siz paylaştınız mı şeyde? Hocam ben bir şey soracaktım ama.
Sor.
Bu dersle alakalı benim Teams'te giremedim ama. Farklı link mi değişti acaba? Okul sitesinden bir link bulmuşum bir tane ama.
Bölümün sayfasında
Link buldum oradan tıkladım.
videonun altında.
Videonun altında. ENG 151 diye vardı. Tamam,
Evet. Evet. Videonun altında.
Bir üye gözüküyordu sadece. Bir üye gözüküyor sadece derste de. Ben de katıldım. Ha öyle mi? Ben de başvuru yaptım da daha gözükmedi, onu sorayım dedim.
Ne zaman başvuru yaptın?
Bugün öğlen.
Dersteydim.
Ya ondan bir sorayım dedim. Yanlış mı doğru mu değil mi? Tamam.
Yani normal ordinary ödevleri ya da programlama ödevlerinde sanal makine mi kullanmak daha mantıklı yoksa
Sanal makine ne yapacaksın?
Ubuntu kurun dediler mi? Laboratuvar derslerinde. Ondan dedim.
Kim söyledi Ubuntu kurun diye?
Sizin tanımıyorum da danışmanlar.
Ha.
Laboratuvar.
Ben onlarla konuşayım. Ubuntu kurmanıza gerek yok aslında. Niye Ubuntu kuracaksınız?
Bilmiyorum ki. İlk ders onu öğrettiler. Quizler.
Standartize olması için Ubuntu'yu sanal kurun. Çünkü Windows'a da ihtiyacınız olacak.
Tamam.
Yani olmayabilir ama olabilir. Sanalda dursa daha.
Kalif olan bu şekilde Ubuntu'da yaptığımız her şeyi yapabiliriz. Bazılarını yapamıyorsun sanki ya.
Ama ummadığın gün abi çalışmıyor demesinler diye yap işte. Aslında Pardus'a zorlamak lazım ama onda da şu çalışmadı, bu çalışmadı olduğu zaman canın sıkılabilir.
Bir şey sorabilir miyim ama önceki dersle ilgili. Hani şurada sıralamayı söylemiştiniz ya şuna gidiyor. Onu tekrar bana söyleyebilir misiniz? Şurada hani aritmetik lojik unit vardı, kontrol unit vardı falan.
Onu yarın tekrar alacağım bir şeyden.
Tekrar.
Bitirmedim, okulun yarım kaldı. Aritmetik lojik unit, aritmetik lojik işlemleri yapıyor. Kontrol unit ne yapacağına karar veriyor. Yapacağın şeyleri de buraya alıyorsun. Mesela mutfakta yemek yapıyorsun diyelim. Tencereler, tabaklar, kaşıklar burada. Dolaptaki malzemeler de burada.
Tamam, yani şimdi burada 4 tane, 5 tane var. Burada mesela toplama çıkartma falan mı? Buradaki olaylar, buradaki
Hayır,
olaylar
bunlar
mı?
malzemeler şeyin burada. İşlemlerin burada. Bunlar malzemeler. Bunlar da yapan şeyler.
Malzeme derken ne demek?
Yani iki tane sayıyı toplayacaksan iki tane sayıya ihtiyacın var. O
Ha.
sayıları buraya alıyorsun.
Tamam anladım.
İşte kaç bitlik register'lar kullanıyorsun? O kadar. Bir sayı kaç bitten oluşuyor? Her bölüm. Her bölümde o sayı değişiyor. Memory boyu değişiyor. Bus boyları değişiyor. Register boyları değişiyor. Hepsi değişiyor.
Bir şey sorayım mı? Hocam Cuma günkü ders hibrit yazıyordu sistemde. Cuma günkü CS107 dersi hibrit yazıyordu.
Hibrit şöyle, bazen gelmeyebilirseniz şeklinde yapacağız. Yani hibrit demek online demek değil.
Ben de onu bilerek gelmedim. Bu komutları nereden
hafta-
öğrenebilirim?
Hangi konuda?
Cuma günkü işleri.
Asistana sor. Mehmet Burak Koca.
Tamam.
416, 32 veya 464 şeklinde değişmiyor mu? Yani bir 32'lik sisteme demek diyerek 64'e yükseltebilir miyim?
Yükseltemezsin.
Ben yanlış biliyorum. Yani benim bildiğim kadarıyla eğer bir sistem 4 RAM 6 ise 32 üretilir.
Hayır. 32 ise 4'ün 6 olur.
Evet, bunu
4'ün 6 ise 32 olmaz ama.
4'ün 6'sı 32 olmak zorundadır mı?
Değildir. Ama 32 ise 4'ün 6 olmak zorundadır.
O zaman biz
Çünkü 2 üzeri 32'yi hesaplasana.
Söylüyor, duruyor.
Ne oldu?
Oradan görünce sanki poz veriyor gibi duruyor.
Evet evet.
Bir şey söyleyeyim mi?
Evet buyurun.
Böyle biz bir ara şey gösterdiniz ya A, B, C falanca dönüyor.
Ne?
Yani nasıl diyeyim? Mesela A harfinin karşılığı
Karşıda
F
evet
gibi.
evet kodla.
Orada 5 tane şey vardı ya.
Evet.
Ama sonra 6 falan oldu. Ben onu anlamadım. 6 da yazdı.
İlk çıkan 5 bulmuş. Baudot 1800 bilmem kaçta. Sonra 5 yetmemiş 6 yapmışlar. Olmamış 7 yapmışlar. Şimdi 8.
Anladım.
4 milyar
4 GB. 2 üzeri 32'de gösterebileceğin farklı sayısı o kadar. 64'e çıktığında 2 üzeri 64 o zaman çok yüksek bir sayı.
o zaman eklemek bilgisayarı bozar mı?
Neyi eklemek?
Engeller.
Neyi eklemek?
RAM eklemek yani.
32 bitlik bilgisayarı 4'ten fazla ekleyemezsin ki zaten. 64'tür zaten. 32 bitlik
Kabul
bilgisayar
etmez.
kalmadı. Hı? Etmez. Etmez. Özel yöntemler var. Birinci bank, ikinci bank gibi, shift tuşu gibi öyle yöntemler var ama istenilen performansla çalışmaz. Yani biraz topal olur yani. Sen hissetmesen de topal olur. Yemiyorum artık. Kaç kere aradım? Muhtemelen Telekom. Efendim? Görüşüyorsunuz. Evet, evet. Evet, evet. Yani ürünü yanlış seçmişiz siteden. Yok, siz iade yapın, biz tekrar alacağız. Evet, evet. Tabii. Çok teşekkürler. Tamam. Ben tekrar şey yaparım. Çünkü çocuk için aldım. Dolayısıyla onunla almak uzun sürüyor. Tekrar alacağım. Çok teşekkür ederim. Çok teşekkürler. Sağ olun. Sağ olun. Okay. Now, let me show my face to. So once you see something is happening in stage one, you see that something is happening. You see a fire is burning. Then you develop a theory. You just go and do experiments. You develop a theory. You have to explain it in words, in numbers. That is a hypothesis to be tested. Without that, I am just exploring, I am doing experiments, it doesn't work. You have to have a purpose when you are doing experiments. Purpose. For that purpose, it is called as theory. Based on that theory and a hypothesis, this is the hypothesis, then you do experiments and realize that you prove that your theory is correct. Any questions? This could be physical sciences, or it could be social sciences. For example, you can have a theory about if you kill murderers, rate of murders will decrease. That is your hypothesis. So we call it as capital punishment, right? Ölüm cezası. Some people are against capital punishment. Some people are pro capital punishment. It is even undecided in the United States. Some states are allowing capital punishment. Some other states does not allow. So the question is, how do we decide? If we go dogmatic way, based on religion and all the beliefs, etc., accepted values, then you can say it has to be done this way. This is correct. But if you are going to do scientifically, you have to make a study, and that study should have a longer span, saying that in the capital punishment states, are we seeing decrease in murders? You make a statistics. If you see decrease in murders, if you cut the hands of the thieves, for example, if it is decreasing, you can say, yes, it is effective, or it is not effective. So you can explain it with science. Obviously, there are other reasons whether killing a person is correct or not, whether they're cutting the hand is correct or not. There are other issues related with that. But in terms of effectiveness, you have to make a scientific study. Yeah. There is a human rights issue, etc. One of the famous example I was giving was whether heroin is better, cocaine is better. Which one is better? In order to test that, you have to make an experiment. And if you give two of them to the same person will die, because you cannot give two at the same time. So how are you going to study? So you will find half of the class given to cocaine, another half of the class given to heroin, and you will compare. So that is what experiment is in between subjects. That's called between subjects experiment. Recently, they invented a pill for COVID-19. It reduces the effect of it is antiviral drug. They give placebo to half of the patients, and actual drug to the other patients. Placebo patients died. So in the study, they let people die, but otherwise they cannot understand the difference. That's what I was going to say. Observation. We design and carry out systematic observations, just the examples I have given to you. And those observations are actually observations for testing the hypothesis or disproving the hypothesis. Either hypotheses are refined and subjected to further explanation, or disconfirmed, disproved, so that other theories must be found to explain the situation. So you checked vodka isn't the issue. So why are these Russian men are dying earlier? You have to find another theory, such as radiation from the North Pole, etc. Then you have to test that theory. Yes, the famous guy, Feynman, is very famous on this. Importance of skepticism. We ask whether the observed data can be explained in another way. Don't jump into conclusion. You have data, vodka, death times. Are you satisfied? Not yet. Think about if there is another explanation. According to studies, it's famous in newspapers, according to studies done in United Kingdom, people who drink coffee make more traffic accidents. So should we drop drinking coffee in order to reduce accidents? Just like cholesterol. Egg contains cholesterol, so don't eat it, and so your cholesterol will be low. So they are related, but not cause each other. They don't cause traffic accidents. But people who make traffic accidents drink more coffee. That's true. Why? Because they have stressful life. They get up early. They have jobs that requires certain vigilance, etc. Then it is causing more accidents. So that is called an example of correlation is not the cause. There might be correlation between two things, but that doesn't mean that one causes another one. They can be related. They can be affected from the same original factor which you didn't discover at that time. So try to find the data that try to disprove, disconfirm the theory. If you can disconfirm the theory, then you prove that theory is incorrect. And all theories are tentative, acceptable, until it is disproved, because it is deducted by logic, by previous explanations, by previous experiments. Under the light of previous experiments, a theory is formed. If you cannot disprove it, you should accept it, because there is a certain basis for it. And the big question is, how do I know whether it is true? How could it be proved false? And that is actually the question of the science, and it is constantly changing. The idea is not to accept things as true or as false. Be in the search all the time. Oh, not that one here. So what is a research method? Okay. So first, you will have some readings. You read, and you think that this must be the way. That is what we call philosophical assumptions. You have some knowledge, and based on that knowledge and knowledge accumulation, you have some assumptions. Based on that knowledge, you design an experiment, you design a strategy, research strategy, and finalize your design and do the experiments. And then you go back rethink your rethink your philosophical assumptions. You have to revise, rethink, and correct your philosophical assumptions based on the outcome of the research. That's all iterations. The rest is not that important. Some of the research, scientific research, can be divided into two. One is quantitative, the other one is qualitative. There is a Turkish versions of those two. Some people say quantitative, qualitative. Actually, the Turkish one is nitel, nicel. Okay. Which one is nitel? Qualitative is nitel. Okay. So there is a misconception, misunderstanding that anything quantitative is research, anything qualitative is not research. This is wrong. Research can be qualitative as well. You can describe, you can classify, etc. It doesn't have to be measured precisely. You can study something scientifically in discussing about, in measuring the qualities. Okay, doesn't have to be metric. or doesn't have to be statistical. Or you can have both of them together. Usually it's better. If you ask people about their preference of political parties, right? You can make quantitative research. This person gives this party, this person gives this party, this person gives this party, and further, you can have qualitative research. Why do they give to this party? Why do they give this party? Their common characteristics, etc. So you can study in more deep detail, and together it makes more sense. This is the mouse guy, the person who invented the mouse and personal computer. He says the key thing about all the world's big problems is that they have to be dealt with collectively. In the old days of science, Descartes, Boyle, Fleming, Pasteur, they were all one person. If you are only one person, you can do certain things. So the big problems, Engelbart says, they have to be dealt with collectively as a team. Okay? The first person who started collective research is actually, aside from universities, in terms of research laboratories, Edison. Edison made a research laboratory in United States, New Jersey, at that time, in the early years of the century, 20th century. They did collective research with multiple people working on the same topic, etc. And he says, Douglas Engelbart says, if we don't get collectively smarter, we are doomed. Our future is dark. So for that part, if you are going to solve a problem, that problem could be problem of the building, problem of mathematical nature, problem of inflation, problem of terror, etc. Any kind of problem. First, you describe it, then try to describe the problem and describe where you want to be after solving the problem. What is your end result that you want to reach? Result of the equation. I am trying to find speed of the rocket when it goes. So those are the results that I want. Or reduced inflation, for example, in our common case. In order to be able to solve it, you gather information, both theoretical and practical. Usually first theoretical information. Think of solutions, alternative solutions for the experiment. Then multiple alternatives might exist. Try the best one for the experiment. Implement this solution. Evaluate the results and make necessary changes. Changes is very important. Make necessary changes and start doing it again. Iterate until you are satisfied. So develop theory, think of solution, implement solution, measure it, evaluate it, and improve the previous theory. This is also followed in technological development of items, technological development of software and hardware, or the machines or buildings, you iterate. And it is usually said, in order to get something done correctly, it has to be done 5 times. That's on the average. So if you have a chair to manufacture, first prototype, second prototype, third prototype, fourth prototype, and the 5th prototype, it becomes a good product in the iteration. And that's important in the science. Leadership is important in order for a nation, in order for a company, in order for a school, university to increase success and increase the success in science depends on leadership. That was the same in Europe. That was the same in Islamic time, in Asia. That was the same in Arabic Spanish times in Cordoba. Today's Europe, in the United States, in Russia. So the leadership and government is very important for science to improve. Turgut Özal was very famous for his attention to computers, personal computers, and playing with the computers, computer games, etc. First university of the world is considered to be University of Constantinople, Istanbul, founded as an institution of higher learning after secondary school in year what? Is this disconnected? In year 1425. When was Hagia Sophia built? Look at telephones. Interactive class. Evdekiler uyumayın. Enes, Alperen, Berke, Murat, Emirhan, Serdar. Huh? 532 finishing time. Yes. 537. So it is before Hagia Sophia is built. There was other probably things in that place. The location of that university is today behind Sultanahmet Mosque. When you go to Sultanahmet, it is behind Sultanahmet Mosque, and there was an old palace. Most of them are ruined, but some of them are intact, and that part contains a carpet store now. Today, you can visit, and there is a page on the web, first university of the world. There were like, I think, 70 or 80 scholars at that time, teachers for university studying. And the property of university was at that time research, an institution doing research, teaching, self-administration, and academic independence. So that is the 4 important thing that makes the university a university. In order to be counted as a university in terms of definition, you have to have research doing, teaching, so creating new scholars, self-administration, so you have to be able to select your president, and academic independence. You have to be able to study whatever you like, separated from the government. That is what is accepted as a university by the authorities. I am going to come back to this first University of Istanbul later in the Byzantium times. I also have pictures of the palace. The university this film is famous, film of Paul Newman. The name of the film is Cool Hand Luke. Just check it up. Check it up so that you understand what I mean later. University creates knowledge, do research. Second, it allows you to improve yourself. Third, empowers students with knowledge. Fourth, interacts with the public. So there will be seminars, courses. Public also can use the library and so on. Giving profession to students, meslek, no. It depends on students. So we are not going to find you jobs here. So there is a misconception about in the public saying that finding job after certain department is correlated. Finding job and the university education is correlated. No, it is not. It is not a job course. It is a university. The name, the position is different. Today, it is kind of shifting to vocational schools, trying to find jobs for people. But actually, in the universal sense, university means a place to do 4 things, not to find a job, not to put you something after you graduate. There is a search engine called Google Scholar. Have you ever used this? Okay. The rest should use it. This is for research, not for finding images and other for popular things. This is for finding research. So the address is scholar.google.com. Google Scholar. If you do search from there, only scientific things come up. So you should use it when you are preparing homeworks, when you are preparing anything, doing projects. There is ACM. ACM stands for Association for Computing Machinery. IEEE is standing for Institute of Electrical Association. What is this last E? Institutes E. The last word of Institutes E.
Elektrik and electronic.
Engineers. So these 2 associations will be helping you for the rest of your life. Those are United States originated worldwide organizations. There is also a chapter of these in our department, in Turkey, in the department and the universities, student branches. There are memberships. The good thing is about that is they have libraries. Those libraries are accessible from the university, our university as well. So any kind of publications like the Royal Society in those years in England, when 1665 Royal Societies, ACM and IEEE supports publications and organizes publications and conferences and provides access to those documents worldwide, including here. That's it for today. If you have any questions, let me know.